Alright, so today what we're going to be talking about and learning is average rate of change. Okay? So when you see rate of change, that's going to be talking about how one variable kind of compares to another. How does one change compared to another? And average means, you know, over the long haul. Okay? So in general. So kind of give you a specific example would be driving. So let's say you're going to drive to your grandma's house. Okay? While you drive, okay, you're going lots of different miles per hour. Okay? Sometimes through the town you're going 25, 30. Get on the highway, you might get up to 55, 65. Okay? Your speed is changing all the time to grandma's house. Okay? If we wanted you to find the average rate of change, or in essence your average speed to grandmother's house, you need to know basically two things. What's the total distance you traveled? Okay, so let's say you traveled 100 miles to grandma's house. Okay? Second thing you would need to know is the total time. So let's say that took 2 hours. Okay? So again, it took you 100 miles to get there, 2 hours to get there. Your average speed would be basically the change in distance, 100 miles, over the change in time, 2 hours. Or on average, you drove 50 miles per hour. Again, point, average rate of change is on average you're going 50 miles per hour. If you went 50 miles per hour the entire time, somehow instantaneously from your house to your grandma's house, never stopped, never slowed down, went 50 miles per hour, you would get there in 2 hours for the 100 miles. Okay? But again, along the way you went lots of different speeds. Okay? So what we're looking for average rate of change is, again, if you kept something constant, how long would it take you, or what would be your average speed to get there? What we're going to look now is a little bit more formulaic of what it means with kind of some functions and equations and graphs, and how we kind of find the average rate of change of those. So in general, what we want to keep in mind when we think about average rate of change is think about the change in your y, distance, over change in your x, time. Okay? So I'm going to give you a function, an equation, f of x equals x squared plus 1. Pretty basic. Hopefully you remember this from previous classes. This is a parabola, U-shape. Okay? So we're going to kind of sketch a graph of what this function looks like. If it helps, if you don't remember, you can always make that little t-chart to help you plot a graph until you can kind of see that general shape. So I'm going to plot -2, -1, 0, 1, and 2. When I plug those in, -2 squared, 4, plus the 1 is 5. -1 squared, 1, plus 1 is 2. 0 squared, 0. You kind of follow along. 1 squared plus 1, 2. And 2 squared plus 1 would be 5. So I'm going to plot those points. And don't need something perfect here, but enough to kind of get the general idea of what the graph looks like. Alright, so -2 up at 5, 1, 2, 3, 4, 5. -1 up at 2, 0, 1. We got these kind of symmetry points. There's a decent looking graph of the function x squared plus 1. Now, when we ask you for average rate of change, since this isn't linear, the rate of change changes. Okay? It's not always going up 2 and over 1, up 2 and over 1. And we're going to be looking at in Unit 2 a lot about what makes something linear, kind of refresh you back on that. Okay? So, average rate of change, the question we're typically going to ask you is something like this. Find the average rate of change on the interval and let's use 0 to 2. Okay? So basically the question says find the average rate of change on the interval 0 to 2. So how much does the y change compared to how much does the x change when I go from an x value of 0 to an x value of 2? Okay? Well, let's think about that. Graphically, what I'm looking at is at 0, at an x value of 0, I'm at 1. So I'm right here. And at 2, I'm up here at 5. Okay? So basically what I want to know is from this point to this one, on average, how much did I go up and how much did I go over? Okay? Well, I'm going up, and I'll do it over here. I'm at a height of 1, and I'm getting to a height of 5, so I went up 4. And here I'm going from 0 over to 2, so I went over 2. So what's my average rate of change? Change in y over change in x. Well, the change in y over the change in x. Change in y was 4, and the change in x is 2. So my average rate of change is 2. Okay? So the idea here is, on average, to get from here to here, I'm going up 2 over 1, up 2 over 1. Okay? But you're going to notice, since this isn't linear, when I go up 2 and over 1, this first spot actually doesn't lie on the curve. Okay? Because it's a curve, not a straight line. Okay? So that's sort of the premise, the basic idea of what we're looking for when we find an average rate of change. We're going to kind of do this same thing, but we're going to use function notation, which is something that you guys worked on earlier in this unit. So same question, nothing different. I want to ask you to find the average rate of change. What we're looking for really is that change in y. Think kind of a little bit like the slope, the y2 minus y1. So we're looking at f of 2 minus f of 0. What's the y value at 2 minus what's the y value at 0? And then we're going to divide that by 2 minus 0. y2 minus y1 over x2 minus x1. So what's f of 2? Well, it's the function value, or the y value at 2. At 2, the y is 5. Pull it from the table, pull it from the graph. F of 0, what's the y value at 0? Well, it's 1. Again, table or graph. Over 2 minus 0. 5 minus 1, there's that 4 that we just found. Over 2, we're getting average rate of change of 2. Okay? So, to kind of wrap it up, what does it sort of mean to find an average rate of change? Well, think about if, instead of being a curve, if this is a straight line between those 2 points, based on your interval, basically what average rate of change is, if it was a straight line, what would the slope of that line be? What we call the slope of a secant line. A secant line is simply a line between 2 points on a curve. Okay? So there's your average rate of change, basically the change in y over the change in x. Okay? We can do it with curves. It's basically how much did the y change over how much did the x change, and really think about how we can apply function notation to do our work for this problem.